Morning everybody. Today we are going to discuss about the deep learning concept. Why you need deep learning? Deep learning allows computational models that are composed of multiple processing layers to learn representations of data with multiple level of abstraction. What do you mean this one? Suppose if you take a scenario of one image containing several levels of abstraction, nothing but you are going to learn in detail of that image by going through that image at several levels. So that is the thing what you say deep learning. At one level I learned something, second level I learned something, third level I learned something, fourth level I learned something. Like that my learning capacity I am increasing, so that I can detect any of that image easily once if I learn in this way. So this type of concept what you call is the deep learning concept. So nowadays the machine learning and deep learning terms are very popular. So these are all building blocks if you want to study artificial intelligence. So when you go to the driverless cars, there you need artificial intelligence. How do you create artificial intelligence? So for that, the backbone is machine learning algorithms. Within that you can use deep learning algorithms. So that is the basic idea of why we have to study deep learning. When you come to the deep convolution networks, so there we can process images, video, applications by using convolution neural networks. On the other hand, we have recurrent neural networks. So there, these are all popular for text recognition, speech recognition. So why you have to study artificial neural network? And within that CNN and RNN, the basic idea is, as a human being, we are following all these things. We have machine learning capacity, nothing but machine learning is developed based on our human brains. Like that, deep learning also derived from human beings. So we have intelligence, that is the reason they have created artificial intelligence. So when you want to study these type of technical topics, existing one is the our neural networks, biological neural networks, which are available in human being. So that is the reason we are creating artificial neural networks. By seeing these biological neural networks, we are going to create artificial neural networks. So same way we can get these capacities, what you call deep learning capacities, and you can introduce artificial intelligence. So that is the basic idea of this one. So that is the reason we have to study artificial neural networks and convolution neural networks in some applications like images and videos. Other case, if you take recurrent neural networks, you want to do text and speech processing, we use this recurrent network. Now if you see the comparison of biological neural networks and artificial neural networks, biological neural network is looking in this way, whereas artificial neural network is created in this way. So here biological neural networks, if you take, this is the cell body taking inputs, and through dendrites we are getting at cell body processing these things. Processed thing is given to axon for transmission, so that like that it will be transmitted. So here even you can work with the synaptic weights also. So your input multiplied by its weights, processed by cell body with some algorithm, and finally you are communicating to other neurons. So this is the biological neural network flow if you take, and the same way we are taking inputs. Why? Because you are getting inputs from various sources like this. The same way here also we are getting inputs x1, x2, xn, and weights, synaptic aids, we are representing as w1, w2, wn. This is the comparison of biological neural networks and artificial neural networks. And here we are doing summation, and even we are adding some bias, nothing but threshold. After that only output you will get. Below threshold you will not get anything. So that is the reason we are introducing bias. After that, whether we are processing on what way here, the resultant output, it purely depends upon activation function. So activation function gives one type of output based on the activation function used. Here you can use several activation functions. Here you can do several processes, addition, subtraction, like that. Anything is possible. So just this is the comparison of artificial neural networks and biological networks. So when you see BNN and ANN, by referring this BNN, biological neural networks, which is naturally available in human beings, we have created artificial neural networks. Then with this motto, we are going to create artificial intelligence with the motto of human beings. Human beings, they have natural intelligence. That is the reason we are going for artificial intelligence. So this is the basic understanding of biological neural networks and artificial neural networks. So the first contribution by McCulloch-Pitts, he proposed this type of thing, inputs and something you say weights and summation, and after that some activation function. So finally you are getting the output. So like this with some more here all weights are taken as one. After that they have introduced weights. You can change weights as per the requirement. So inputs, weights, and then summation, then activation function. Activation function may not be the same always. You can change. Here if you see activation function, and here if you see activation function, both are different. So based on this activation function only you will get the output. Now, to better understand, I am going to explain with one example. If you take this is the example, we have one warehouse. It stores the fruits. So when fruits are brought from outside, you have to keep in various locations based on the fruit. Suppose here you have two fruits you take as an example. So how do you work out this scenario? Suppose you take apple and orange. Then you have to sort these fruits and you have to keep in respect to locations. So fruit is entering here and sensors capturing the details, nothing but features of these fruits. Accordingly, your sorting algorithm is keeping apples in this location, oranges in this location. So if you want to implement with the alpha of this one by a neural network, how do you do? Now here fruit is described by three features. One is shape of fruit, texture and weight of the fruit. Shape can be anything, texture can be anything and weight can be anything. Suppose when you see these two fruits, apples and oranges, the shape sensor will output a 1 if the fruit is approximately round. And if the fruit, apple or orange, if you take, it is approximately round, then how do you represent that one as 1? Suppose a fruit with elliptical shape, then you represent with -1. Another case, texture. Texture case, sensor will output a 1 if the surface of the fruit is smooth. Suppose apple, if you take smooth surface. Suppose if you take orange, that is not the smooth surface, it is rough surface. So apple case you are keeping 1, orange case you are keeping -1. Then coming to the weight sensor will output a 1 if the fruit is more than 1 pound and a -1 if it is less than 1 pound. Suppose you are considering almost similar weight, then your apple and orange is denoted as 1. So here if you see this features, shape, texture and weight, shape both are similar, so we are keeping as 1. Texture both are different, apple smooth, orange rough. Weight both are same, we are representing 1. So how do you model this problem? So for this one, we are taking shape, texture, weight. Orange case, texture, texture, so indicates -1. And apple case, smooth 1, we are keeping 1. And weight case, here we are considering weight is more than 1 pound if it is 1 and -1 if it is less than 1 pound. In this design modeling, we are considering that weight is less than 1 pound in both the cases. Orange case is less than 1 pound, apple case also less than 1 pound. So that is the reason we are keeping -1 and -1. This one indicates shape almost round in shape. So orange and apple both round in shape, weight same, but only texture difference is there. Then how do you model this one? We have to resolve this one. We have to solve this problem. Whenever a new fruit come into the picture, you have to keep in a right place. For that you have to build artificial neural networks. If you build such type of intelligence, automatically fruit comes into the decision boundary. Then you are taking a decision and you are keeping in a proper location. That is our interest. Here we are taking the activation function as like this symmetrical hard limit. So symmetrical hard limit indicates up to 1 point, if it is greater than or equal to 0, you are getting +1. This is the t greater than or equal to 0, you are getting +1. T less than 0, you will get -1. This is the -1. This is +1. T greater than or equal to 0, your output is +1, otherwise -1. So for this, we are considering +1 for apple, -1 for orange. So that is the requirement. Suppose if you give a fruit to this algorithm, output is +1, it is kept in apple location. Output is -1, we keep in orange location. So every fruit is processed like that. For that you have to create some intelligence. How you are going to create that intelligence? That we are going to discuss. If you see the two input features, you want to build a intelligence. You want to build some algorithm, learning. Then if you observe these two things, orange and apple, first a small x1 if you take, this case small x1, this case small x1 both are same. Small x3 third input if you take, this case and this case both are same. But if you take x2, orange is -1, apple is +1. So x2 is acting as a boundary form. So x2 0 you take, x2 0 if you take, if it is less than this, then you can discriminate as orange. If it is greater than this, you can discriminate as apple. So boundary you are able to identify by comparing these two. We are taking small x1, small x2, small x3. Here also small x1, small x2, small x3. By seeing these two, carefully observing, the only difference is at x2. So here if you form a decision boundary, then automatically it can differentiate orange and apple. That is the reason we have taken x2 is equal to 0. So that is the boundary at x2. If you define a boundary, if it is less than that, you will get orange. If it is greater than that, you will get apple. Plus indicates apple, -1 indicates orange, +1 indicates apple. So when you take x2 0, you want to make x2 0. So how do you do? We know this is x1, x2, x3. Small x1, x2, x3. So small x1, x2, x3. Now you are multiplying with 0, 1, 0. Then automatically this becomes 0, it becomes 1, this is 0. Then it becomes x2. Anyway, bias threshold we are taking 0. So output becomes 0. So what is this equation? This 1 is nothing but x2 is equal to 0. So here x2 0 plane we are representing mathematically like this. These are all inputs. These are all weights. This is bias. So we are designing these weights. Once you design these weights and once you design the bias, then whatever may be the input value you get, that input is processed with these two things, you will get output. Therefore, according to this design, what are the weights you have? 0, 1, 0 weights, bias value 0. So whatever may be the input you get now onwards, we are going to utilize this learning things to take decision. So now we are going to test phase. Suppose during transportation, orange shape is changed. Why? Because that is a flexible. Orange can take different shape also. But whereas apple is hard in nature, so you cannot change the shape. So when orange, actual original property of orange is 1, -1 and -1. But due to transport, this whatever may be the round shape modified into different shape. That is the reason we are not taking 1, we are taking as -1. So your input vector then becomes -1, -1, -1. Why this is -1? Now it is not in round shape. That is the reason we are taking -1. So the response of the network now, if you see, we know weights. Already we have designed, we have learned, we have that intelligence with us. Now 0, 1, 0. Bias also we have 0. Now only new input come into the this as input for this total build algorithm. So what is the input? -1, -1 and -1. So -1, -1, this is the input. These will not change, this and this. Whatever the input you get will process with this one and result you will get. So if you take 0, 1, 0, -1, -1, -1 and 0, this 1 and -1 becomes -1. So -1 is less than 0, then according to the activation function, if it is t less than 0, output will become minus 1. So output minus 1, as for the earlier this one, minus 1 indicates orange. So we will keep this fruit in orange location. So this is the idea of how we are going to develop this type of intelligence automatically. Now machine already learned something, that learned thing we are using for any unseen situation also. So this is the basic idea of the machine learning. This machine learning can be implemented with three types of possibilities. One is supervised learning, second one is unsupervised learning, third one is the reinforced learning. What is the difference if you see? Supervised learning case, teacher is available, everything taken care by the teacher. So with the presence of supervised, nothing but a mentor, nothing but a teacher here. A supervisor is available with you. Then you are working, you are learning. Nothing but output is known for us. Nothing but labeling known for us. Suppose we take apple, apple label, orange label, like that banana label. We start learning. Why? Because labeling already there. This type of environment, what you say is the supervised learning. Coming to the unsupervised learning, no teacher is available. You have no idea about apple, orange or banana. Just based on the properties of these fruits, you are keeping apple in one location, banana in one location. Why? Because the apple shape is round, banana shape is different, color is this color is different, that color is different, like that. Even though there is no teacher also, you are learning by based on the features. Without labeling, you are working. So that is the unsupervised. Third one is the reinforced learning. Here, teacher present, but he will not expected or desired output, he will not indicate. What is the required, like that labeling, he will not discuss. Suppose you do something, you learn something, that learned thing is right or wrong. Suppose if it is right, learned thing is right, reward is given for you, or otherwise penalty is given to you. Here we are not, teacher is not giving any labeling, and you have not given that type of input for you at this junction. Teacher responsibility is, if you do correct answer, he will give some reward. If you do wrong answer, he will give penalty. So this, by seeing this reward and penalty, you are learning. So that type of environment, what you call is the reinforced learning. So three different possibilities: supervised, unsupervised, reinforced learning. So when you take the first case, supervised learning case, you are taking input, processed, you are getting output. This output is compared with the desired target. Then we say supervised learning. Whereas in the second case, there is no target. Without that, we are doing. Third case, we are observing, that is the third party is observing, nothing but teacher is observing whether whatever may be the learning phenomena here, is it right or not. Based on that, he is going to give award or punishment for that one. So here the feedback obtained is evaluated. So based on that, you are going to give either award or punishment. Here complete monitoring is there. Here you are judging whether you are moving in right way or this wrong way. whereas unsupervised, no teacher aware. This is the scenario of supervised, unsupervised and reinforcement learning. If you take one example of a number 287635, by seeing this you can easily identify. Why? Because human brain, we have some intelligence, that is the reason you are able to identify. But coming to the system, if you give this type of input 287635 image to the computer, it cannot recognize. Why? Because 2 keyboard 2, if you press, it can recognize as 2. If you press 8, it can recognize. Like this situation, if you give, it may not recognize. So for that, you have to learn, you have to give training for the computer. If you give proper training to the computer by considering various digits like this, zeros, ones, twos, various possibilities, if you give training, then automatically inside we are building some algorithm to recognize all these numbers, whatever the shape, some angle, like that, any possibility is there also. Finally, computer can identify as 0, 1, 2, like up to 9. So earlier, without this type of training, you cannot recognize it. But now with this type of training, you are going to learn the things. So this type of thing, what you say is the machine start learning things. Machine learning is going on. You're keeping some algorithm there, and you are keeping some well identified weights and bias. With this, once you have weights and bias, then whatever may be the input you give, that input is processed with these weights, designed weights and bias. Automatically, you are going to recognize as the deceit. Now, if you take one situation, you take inputs x 1, 2, 3 like that, weights 1, 2 like that, bias you are adding. Here we are doing summation. Bias is nothing but threshold. If you cross that threshold, then you will get the value. If you don't cross that threshold, you may not get the value. After that, activation function is applied. So that is the reason here threshold is nothing but bias. That is the reason we are keeping minus. So remaining weights and inputs are multiplied here. So all these multiplications and summed, and we are subtracting the bias value. That is whatever the thing you are getting value, on that we are applying activation function. So your this multiplication of xi wi is greater than or equal to threshold, nothing but bias. Then this is greater than or equal to threshold, then you are taking output 1. Suppose if it is less than this value, your output is 0. That is the function of this one. So when you want to represent this one wixi, generally we represent with summation of wixi. In mathematically, if you want to represent as a single vector quantities, we take W transpose and X. Why? Because W transpose containing one row, so many columns. Your X, so many rows, one column. If you do this type of multiplication, resultant will be one single value. Why? Because 1, suppose you take 4 here, 4 columns. Here 4 rows, 1. So 4, 4 will be cancelled. This one and that one, resultant will be 1. So that is the mathematical representation. Now I am taking inputs 5, 5, 3 and different weights 0.8, 0.3, 0.5. I am taking bias value 3. This bias is subtracted from this summation. That is our commitment, our algorithm. Bias indicates threshold. So if you 5 and 0.8 multiply, 5 and 0.3 multiply, 3 and 0.5 multiply, and if you do summation, you are getting the value 7. Now what is your threshold? 3. So 7 is greater than 3, then your output is 1. So instead of keeping bias like this, if I bring this bias also as input, then we are representing that one. as this one always 1, this weight, whatever may be the thing you want, we are representing it minus. Now earlier we have taken I is equal to 1 to n, now I is equal to 0 to n. Why? Because bias also added like as an input. So this is bit easy to manipulate and mathematical handle. So that is the reason we have changed. Now bias also taken into the input. Now we are comparing with I0 to n all summed value greater than or equal to 0, then it is 1, otherwise it is 0. So simplified diagram, when you compare previous one, all these things simplified as the single diagram. Like this you can work out. In the previous example, anyway we have computed this is 7. Now bias value 3, we are keeping minus. So in the summation automatically 7 minus 3 you will get 4. So 4 is greater than equal to 0 condition satisfying, then you will get output 1, the same as earlier one. So this is the introduction point of view. We want to create a biological neural networks type of capacities with artificial neural network with this type of algorithms. So this most of the content is taken from the internet, and you better study by typing that type of word in internet. You will get further details also. So thank you for your understanding.